All right, welcome to part two. I know I said I was going to start with part B, or question B, 4B. But I want to go back and talk about this for a minute because I know some of you are looking at this going, hey, wait a minute, that's a quadrilateral. Hey, wait a minute, that's a parallelogram. Um, yes, you're right. Notice it says most accurate name. So what do we mean by most accurate name? Another way to say that I think would be most specific name or something like most highly elevated name that the quadrilateral deserves. I don't know if you know people like this, but there's people in life you're going to come across, especially when you get to college, who have doctorate degrees and they want you to call them doctor. And there's people who don't, and you're supposed to call them Mister. And if you go up to someone who's supposed, or Mrs. or Miss, and you go up to someone who is a doctor, but you call them Mister or Ms. or Mrs., they get somewhat offended because, like, wait a minute, I went to all that schooling. I became a doctor. I know I'm still a Mister, but you know what? I would prefer you call me doctor. So it's that kind of thing with these. Yes, this is a quadrilateral. Yes, this is a parallelogram. But you know what? Rectangle's the best name it deserves. And by best, I mean most specific. It's got the highest kind of hard to attain definition of all those things. And that's why I kind of hope this organizing chart, or actually even this one isn't bad, gives you an idea of of the names that are possible here. Which kind of name is the best? Square is the best name ever. If you can say something earns the title of Square, Square is like the ultimate Jedi ninja name available for any of these quadrilaterals because it's the most specific. It's got all the angles are spoken for, all the sides are spoken for. It's by far the hardest name to attain. It's the most specific, quirkiest, specific quadrilateral we have. Slightly, right before that would be rectangles and rhombus. They're kind of like the deputy most special quadrilaterals we have. Before that would be parallelograms. Of course, all of those things I just mentioned, everything on this page is parallelograms and quadrilaterals. But parallelograms would come second to a title like rectangles or rhombus, and that would come before squares. Squares would be by far the best one. Hopefully that all kind of is making sense by now. If not, of course, this is only a video, and you'll have me in class, and we'll talk more. All right, so now with this one. So here's another collection of facts we know about this quadrilateral. What's the best name it deserves? Well, it's got 3 right angles, so it would be really nice if it had 4, we could say, well, that's a rectangle. But think about this. It's a quadrilateral. Quadrilaterals have to have a certain angle sum, right? It has to have 360 degrees total. We've talked about that already. So, this isn't working. Oh, there it is. So that has to be 90 also, just to make 360 in this thing. Therefore, right here, we've met the definition of rectangle. Can I say it has to be a square? No. There's no reason why this thing couldn't look just like that last badly drawn rectangle I had. In other words, I can make a really crazy version of this that has all these properties that really is not a square. So I can stop right there at rectangle. All right, C. Given these parallels and all 3 sides of it are congruent, what has to be going on with this thing? Does it have to earn the term parallelogram? Oh, wait, I think it does have to earn parallelogram because it has that and that. Right there, that was enough to meet one of the requirements of parallelogram. Great. Does it have to be a rectangular rhombus? And rectangular rhombus are kind of equivalent. I don't know if you've noticed that by now. But rectangle and rhombus, maybe this kind of makes it obvious. Rectangle and rhombus are kind of at the same level in terms of, oh, this should make it obvious too. Rectangle and rhombus are kind of, I don't know, parallel. I shouldn't say that. Rectangle and rhombus are equivalent in terms of their status in this whole hierarchy of things. So I shouldn't. No, it's not like I go from one to the next to the next to the next, looking for the best possible name. These kind of share the same stature in terms of the quadrilaterals. All right. So after parallelogram, does this have to since these 3 sides are congruent, does that have to be congruent? Boy, I don't think you can prove that. I know it's really tempting. And again, I know you're thinking, well, if it's a rhombus, then it would have all these things true, but that's not the question. The question is, if this stuff is true, does it have to be a rhombus? Does this 4th side have to be congruent to those other 3? Ooh, how am I going to figure that out? Well, these are parallel, right? So I could do, you might think about doing something like this. Let's throw on this, if I could hit the target there. this angle is congruent to this angle because of AIA. I could draw an AIA thing like this also. Notice I'm really not sure how things are going here. I'm trying to get at this fourth side, or this fourth angle, or these other two angles. Can I say anything? Like if this was parallel, then I might have somewhere to go. Remember, because if it's a parallelogram, oh wait, I think I just talked myself into it. If it's a parallelogram with two congruent sides that are neighborly, ooh, I think I have that. Kids, look at this one. If I have two neighborly congruent sides, let me get rid of the other stuff I drew in here. Then that makes it a rhombus. Oh, there it is. Did you notice how I was kind of stuck on that one? All right, so let's cut out all the chit chat here. I have a parallelogram. Parallelograms with two congruent sides have to be rhombuses. All right, so now I'm at least a rhombus. Does it have to be a square? Now the only way it's a check mark. Check mark, yes, rhombus. If it's a rhombus, then its only other possible elevation to a higher name would be square, and that's if it's also a rectangle. So is there anything that says this has to be a rectangle? I don't think so. I think I could draw some crazy rhombus that's really slanty that would have that true, and of course that true, and that true, and that true, and that true. Sorry for the extra mark there. But it's really not a square. So I think I have to stop here at rhombus. That was a hard one. That's a good one. All right, D. Well, we have right triangles here, sharing a diagonal. Does it even have to be a parallelogram? Wow. These are two isosceles right triangles. So let's think about this. This is an isosceles right triangle. This is an isosceles triangle. If it's isosceles right triangles, I know that that angle is congruent to that angle. Not only that, these are both 45, aren't they? Because it's an isosceles right triangle. Same with this triangle down here. It's an isosceles right triangle. So that's 45 and that's 45. Oh, bingo. That's a right angle. That's a right angle. So we at least have rectangle. Oh, that's huge. Rectangle, and I think if this is if these are, well, if it's a rectangle, first of all, then it's a parallelogram. This divides the thing into two congruent triangles. We've been over that before. Also, opposite sides in any parallelogram, and by getting to rectangle, we've gotten to parallelogram. Opposite sides have to be congruent, so those are congruent. Let's see what I did there. I did make the double marks. Those are congruent. Notice all four sides are congruent. We got right angles everywhere. We have attained squarehood. That doesn't always happen. Okay, last thing we gotta do is a proof. All right, so let me fill in the stuff. All right, just finishing up here. All right, we're given that we got congruent triangles, PSR and QRS. That's huge, right? PSR and QRS, congruent triangles, that gives us 6 spin-off facts right away from CPCTC. I'll only list the ones I think I need. PSR, well, here's one. PSR is 90. Well, hello, PSR is in that triangle. So let's use QRS as a CPCTC thing. I would let you write it this way. The book might not say it this way, but technically CPCTC is that QRS is congruent to PSR. But you know what? PSR, yeah, PSR, QRA, right, it's gotta be that way. This one's congruent here. Not sure if I'm gonna need anything else, but I was headed to rectangle hood, so I'm thinking, you know what? I'm gonna want the cursor copied there. Interesting. I'm gonna want as many right angles as I can possibly get, so that's great. Thinking about how I might get to rectangleness, I was just saying, definition of rectangle is a good one. So if I could prove that all the angles are right angles, that'd be great. But that's not the only way to skin this cat. It's not the only way to say, yes, I've got a rectangle. Remember we said all this stuff about biconditionals? Yeah, this is a biconditional here too. If a parallelogram is a rectangle, then its diagonals are congruent. Biconditional means it works the other way. If the diagonals are congruent, then it's a rectangle. Is there anything else we have about rectangles? So I bring that up because this would be another way to show that it's a rectangle. If these long green things are congruent, then it's a rectangle. This is about rhombus, this is about rhombus, so I think this is about it. This is our only way into the rectangle kingdom other than the definition. The definition would be great, but I'm just thinking I'm hitting a brick wall here because I don't think there's any way I can get the big angle at P to be 90 or Q to be 90. I don't know anything about this segment PQ. It's not talked about in my triangles or any of the given at all. Well, this was nice. I still don't even know that it was needed. So you know what? I could almost even just erase angle number 2, because I can get these diagonals congruent really fast. Oh, wait. Does it have to be a parallelogram? Does this have to be a parallelogram? If parallelogram is a rectangle, then its diagonals are congruent. If the diagonals are congruent, does it have to be? Oh, it has to be a parallelogram for the biconditional to work. All right. So this is going to be parallelogram. This is what I'm going for here. With congruent diagonals. That's backwards of the theorem I was just given. On the theorem list, it'll allow this to be part of a biconditional, but for now I think this is a little more specific than you need, but it's helping you see where I'm going with this. And yeah, I'm pretty sure I can get to this one. All right, turns out I think this isn't actually going to be helpful. If QRS is 90, I've got this right angle here. I need to show that I have a parallelogram here. So with this right angle and this right angle, I think this is fairly easy. I could now say that PS is parallel to QR. It's the one that says if two lines are both perpendicular to the same line, so they're both perpendicular to SR here, then they're perpendicular to they're parallel to each other. Two lines perpendicular to same line are parallel. It's on the theorem sheet. Then, check out what I do here. I'll say these are congruent. If those are congruent, then what do we have? Think about that as I write this out. They are congruent by CPCTC. Well, yes, why did I do that? I've got this thing again. And we used this in one of the previous examples. Oh, right here. When I had sides that were congruent and parallel, that makes it a parallelogram. So PQRS is a parallelogram. And that's the one pair theorem. I can't remember what it's called on the theorem sheet. Something like one pair, opposite, congruent, and parallel. I wrote that backwards from what I said, but that's it. Now I just need the congruent diagonals, which I can get really quickly by CPCTC. I barely have enough room. Okay. And that is to say PR, I could actually have crammed this into an earlier step. I could have put this in part of 2 or part of 4, but I'm just going to put it in where I need it. PR is congruent to QS. That was from CPCTC. Now I have congruent diagonals in my parallelogram. It's a parallelogram and it has congruent diagonals. That's going to make it a rectangle. That was kind of tricky. Not all proofs on quizzes or tests are going to be this hard to get to. But those are the types of things you got to have available. I used 2 or 3 of them here in one proof. They may not all need quite so many tricks. All right, this video's gone long enough. I will see you next class.